Induction is another way to stabilize a conjugate base. So if we start with acetic acid, this is acetic acid right here, and the acidic proton on acetic acid is this one. That proton has a pKa value of approximately 4.8. So if acetic acid donates that proton, these electrons in red here are left behind on the oxygen, which gives the oxygen a -1 formal charge. So on the right, this would be the conjugate base to acetic acid. If we compare acetic acid to our next compound, this is chloroacetic acid. Notice we now have a chlorine attached to this carbon. Now, I didn't draw in lone pairs of electrons for chlorine just to make it easier to see. So the acidic proton on chloroacetic acid is this proton, so then these electrons in red are left behind on the oxygen, giving the oxygen a -1 formal charge. If we look at the pKa value, the approximate pKa value for this proton, it's about 2.9. So think about the difference in acidity between chloroacetic acid and acetic acid. You're going from 4.8 to 2.9. The lower the pKa, the more acidic the compound. And that's approximately 100 times more acidic, right? This is 2 pH units. From 4.8 to 2.9 is pretty close to 2 pH units. So that would be 10 to the second power, or 100 times more acidic. And so chloroacetic acid is much more acidic than acetic acid. And if we look at the conjugate bases, we can understand why. So this conjugate base must be more stable than this conjugate base. And we can explain this in terms of induction. So if we look at the difference, right, we know we have chlorine here, and chlorine is an electronegative element. It's much more electronegative than carbon. So chlorine is going to withdraw some electron density this way. And if you withdraw electron density, right, you delocalize this negative charge. You spread out this negative charge. And that stabilizes the conjugate base. And since this conjugate base is more stable than this conjugate base, chloroacetic acid is more likely to donate its proton than acetic acid. And we can see what happens as we increase the number of chlorines. So down here is trichloroacetic acid. We have 3 chlorines. And the pKa has lowered even more, right? Because now we have all of these chlorines here withdrawing some electron density. So all of these electron withdrawing groups, if you will, are withdrawing electron density, and that's stabilizing this conjugate base. That's spreading out this negative charge. So this is the most stable conjugate base out of these 3. Therefore, this is the most acidic compound out of these 3. The inductive effect falls off over distance. So if we look at this acid here, this is called butanoic acid. So this is carbon 1, this is carbon 2, this is carbon 3, and this is carbon 4. So this proton has a pKa value of approximately 4.8. If we compare butanoic acid to chlorobutanoic acid, so this would be with a chlorine on carbon 2, so 2-chlorobutanoic acid, the pKa value has dropped to 2.8. So again, that's because of the inductive effect, right? We have an electronegative atom withdrawing electron density, stabilizing our conjugate base, therefore lowering the pKa value for this proton. Now, if we move the chlorine to the third position, right, this is carbon 1, this is carbon 2, this is carbon 3. So now the chlorine's on the third position. So this is 3-chlorobutanoic acid. The pKa value is still lower than 4.8, right? 4.8 was the original pKa value for this proton. Now it's 4.1, but notice it's not as low as it was in the previous example. So with the chlorine on carbon 2, the pKa value was 2.8. When the chlorine's on carbon 3, the pKa value is 4.1. So still more acidic than the original butanoic acid, but you can see the electronegative atom is further away from the negative charge, and that decreases the effect, right? The chlorine is further away from the negative charge than in this example. And finally, you can see the effect even more. If you move the chlorine to the fourth position, right? This is carbon 1, 2, 3, and 4. If you move the chlorine to the fourth position, now your pKa value is almost back up to 4.8, so it's about 4.5. So this chlorine is further away from this negative charge, and that decreases the inductive effect. And so this compound is still a little bit more acidic than butanoic acid, but the effect is greatly diminished.